Hello, welcome. Hello from Houston. I'm sitting in a hotel room here, and this will be another day that if you're following along with the class and you're not in my class, you probably want to wait and back out of this one and wait till this weekend when I get a chance to record lecture 7, because this 100% builds on it, and it probably won't make sense to you if you're following along. I am doing this to keep my class up to date. I'm supposed to have lecture tomorrow. Obviously, I'm in Houston and will not be here to or there back in Toledo to lecture them. So I told them I'd get a recording up, and so that's what this is. So this is day 8. It is the 8th class I have with them. Almost a third of the way done. It's kind of crazy to think about. And we're going to cover the second half of cross-site scripting, which is DOM-based. I will start this lecture by saying that this is a really difficult concept to understand, and I really almost was tempted to just say, you know what, this is going to be too hard for me to try to explain via video, so we're going to do it in person and not have any lecture today, but I figured this will put me in a good spot to be able to give them some foundational, or give the students, you, if you're listening to it, some foundational stuff that we can use. And then we will continue discussing this topic next week on Tuesday when I'm back in class. And I'll use some whiteboard. It's a lot easier if I can draw. It just so happens that sitting here in a hotel room, I've got a mic on, I've got my laptop, I'm using my iPad as a second monitor. It's too much for me to try to draw on whiteboard and everything here and do this and give it justice. So what we're going to do is we're going to explain the core concepts here. This lecture probably won't be super long. And then next week, we're going to do this. I'll rehash some of the things we talked about for maybe 10 minutes when we get there. And then we'll whiteboard it and we'll spend the lion's share of the class going through demos and trying to teach you guys to do it. All 3 of them, we'll go through the examples in DVWA so you guys can get some hands-on experience doing this before we ask you to do it in a lab. The end result might be that maybe next Thursday that you don't get a lecture out of me. We'll see where we land. I think it's a natural good stopping point before we hit cross-site request forgery. I think after we do cross-site request forgery and CSP and other things that are defenses against that, it's probably a good spot to break for midterm. So we'll probably think about doing that. But yeah, here we go. So today we're going to talk about the other common type of cross-site scripting, which is DOM-based, right? So in this case, the browser really does become the vulnerability. There aren't server-side pieces of this in many cases, right? So in the last class, we talked about both stored, where the data ends up being persisted on the server on the backside, and it ends up being reflected or stored, given to every user that hits the page when they do it via something like maybe a comment. I encourage you guys to go play. Then we also talked about reflected, which they're not stored anymore, but they're given back to the user at the time of it. Right. Today we're going to move on to abusing trust entirely within the browser. There are no server-side components to this. Not saying that server doesn't play a part in it, but generally there is no server-side component of this. This is an attack that is entirely browser-based. So again, we saw that. I kind of just covered this slide. I'm getting ahead of myself a little bit. But the thing of note here is the first 2, stored and reflective, are both server-side problems, right? They're server-side lack of escaping, server-side lack of context, server-side abuse of how we store things, right? Just not paying attention to the things we're doing. But again, they're both server-side, right? Like they both require vulnerabilities on the server. Converse that to today's shift, right? Today's shift is DOM-based, right? And we have a slide, I think it's probably the next slide, where we talk about this a little more, but DOM-based cross-site scripting is different, right? The payload probably never sees a server, right? All of this happens client-side. So the server may have done its job entirely. It may have done all of the sanitation that it needs to do. And everything may be great from the server side. The backend team has done an amazing job of ensuring that the application is secure. There's no ability to do cross-site scripting. But this one, because it happens entirely inside of the browser, the HTTP request and reply can be 100% safe, and we can still have a vulnerability. So why does this exist? Well, we spent a lot of time talking about architecture, and we spent a good amount of time talking about how web applications are built. And in this class, we've been taking a somewhat naive view, right? Like almost everything we've talked about here are, client makes a request, server may hit a database or third party, right? Server gathers information, server sends request back to, or sends data / page back to client, client renders page. Right, but modern web applications aren't just that, or they're not that at all, right? These are single page applications where the majority of logic, I'm not going to say business logic, but the majority of logic, and yeah, some cases even business logic, lives client side, right? The client side logic is what is executing things here, right? So to do that, we use JavaScript. And one of the things that we do in JavaScript is we modify the DOM as we need to change things or display data, right? Like that, this is information this is where view page source fails you, right? Like if you've ever loaded one of those web pages and you viewed source and it's like nothing there but loading some JavaScript, that is this in action, right? Like all of the actual work modifying or displaying the browser is handled with client-side logic. So it occurred to me, the original, as I went through the slide deck, didn't have this slide in it, but as I went back and reread it, I'm like, oh man, I'm saying this word DOM a lot. What is the DOM? Well, the DOM is the document object model, right? And it is an in-memory representation of the page, right? It has all of the elements of the page in some sort of like dynamic tree in memory, right? And it's created from the browser after the full HTML loads. And what we see frequently is that the JavaScript can read from the DOM and it writes to the DOM. And it does this frequently in single page applications. The entire premise of something like a React-based app is the fact that you can do this DOM modification dynamically. It is the underpinning of modern web application. So what is this type of attack versus a stored and reflective? Again, I know I'm repeating myself. I repeat myself to drill it into your heads because this is foundational stuff that's important. I try not to repeat myself if it doesn't matter, but if it matters, you'll often find me saying the same thing multiple times because I want you to remember. These are key facts that I want you to take away. And as a matter of fact, if you're thinking about it logically, what am I likely to test on? Key facts. These are things that you probably ought to commit to memory because, as you go through your careers as red teamers or blue teamers, these are the foundational pieces that matter. So the thing that you need to know about a DOM-based attack is it happens client side, right? It does not happen server side. Both store and reflective, on the other hand, happen server side. They rely on the server sending data back to you. And the big key thing here is like it might rely on some pieces of the server that put it in an unsafe space. It almost certainly does, right? Because at some point or another, the JavaScript that's doing unsafe things got delivered to the client, right? But in many cases, that front-end application that runs in JavaScript is written by an entirely different team. It's served generally as a static file, right? There's no computational stuff that happens on the server side. This is a static file that gets delivered to the client as JavaScript, and then the client runs it, right? So backend teams miss this in security scans because they're not responsible for it, frankly. So there's a mental model that I'll transparently say, and I think Dua asked in our class the other day about DOM-based cross-site scripting, and I admitted that this is some of this stuff. I'm not the best JavaScript programmer. I do okay. I understand the DOM. I understand all the stuff in it, but man, some of the stuff is just black magic, right? So I spent I don't know, probably half the plane ride down here, expanding my knowledge on this so I could teach it to you in a way that did it justice. And the mental model that I found in my brain that made the most sense is we have two pieces here. We have a source and a sink, right? So the source is, where am I injecting data into the application? Where does it come from? And the sink is, where does that data land? It's where am I going to do bad things with the data that I receive. So let's talk about those two things. So what do we see for common sources? Well, two common ones that we see are two JavaScript elements. They're called location hash and location search. I had to look these up because I'm like, those don't make any sense. And again, JavaScript is my language of choice. I kind of hate it as a language. But look, I'll explain these simply. Location hash is if you've ever hit a web page and you hit what's called an anchor, I think. It's like basically a pound sign or hash sign that's got an element in it that references a part in the page. That is called the location hash. Right? You can put any amount of data in there. And it's pretty common to see single page web applications abuse this hash to pass user data, right? To basically pass things like what filter are you applying, or what subpage are you on, or other information that the browser needs to be able to tell what you're doing. And the reason it does that is this is a spot that the server doesn't care about. It completely ignores it. Right, like it gets sent in the request, I think. Maybe not though even. I'd have to actually test that. But the server doesn't use it. And the second is the location search. This is a fancy terminology for basically the query string, right? So if you're looking at a URL and you do a question mark and then put stuff after it, like we were doing that the other day in class when we were trying to use get instead of post to do the login for TVWA, right? Like we were abusing query parameters. That's what apparently the browser people have decided is the location search. And those are two common places, probably the most common places that data is referenced, because oftentimes, right, like you see it echoed back to the client to give you information about like what page am I on, or if I'm building like breadcrumbs or whatever the case is, that stuff is fairly commonly echoed back out. Other places we can get this data, refer, right, like that's another element. Yes, maybe, I don't know, I don't really see browsers that are rawly echoing out the refer without doing something to it. So yeah, it also exists. Maybe we'll test it and see if it's present in any of the examples we look at. The last place is browser storage. I've made a reference to the fact that on top of cookies, there is browser storage where you can store data. It's actually pretty common, especially in single page applications designed to run offline, to store data there. Like maybe you make an entire web page or web page component that gets dropped to that browser data because it's easier to just pre-compute it and then just save it to the browser data and put it back to you later. Right? Like if I can modify that browser data, I might be able to change what's happening. So what's dangerous as far as the sinks or where we put it? Well, the most common one is something called inner HTML. And what that generally is HTML is this concept of div tags, right? Like that they're containers that hold HTML. Well, you can reference that HTML in JavaScript using the inner HTML tag, and it's pretty common for these single page applications to just write to it, right? Like that. So by far, that is the most common place that this is done. The two other secondary places, document.write. I've seen this less commonly where I've actually come across this, but it is still used. You can use document.write to echo stuff out to the page. And the last one is eval. Should go without saying that you should never pass user supplied input to an eval, but here we are having to talk about it in class because people do. So what does eval do? Well, it just executes whatever you've passed to it as JavaScript code, right? So like you don't even have to pass that stuff in a script tag. You can just rawly send it in. I keep picking on N8N. I believe a couple of the recent vulnerabilities in N8N were abuse of the fact that it was evaling unsafe data. So that is one that is used for sure. So putting all of the components of this that we have together, what do we have here? Well, we have a source, right, that supplies the data, that gets passed to a sink, and that sink receives the data, and the combination of these two things together form our DOM-based cross-site scripting, right? Like the data flows from the source to the sink without validation, and the browser naively executes the code. So And again, this is going to be a pretty short lecture. I'm just setting some foundational things here because it's really hard to discuss this. Other than this, it's a lot easier to show it unless you tinker. So that will be the lion's share of what we do when we're back together again on Tuesday. So why is this hard to defend against? Well, how do we defend against things? Well, we do validation. We use web application firewalls. Both of these things fall apart in this parlance here, right? Like if this is happening entirely on this website or the client side and it doesn't involve the server at all, there is no web application firewall that's going to save you there, right? Like it just doesn't exist. It doesn't pass through it. Input validation has already happened at this point, right? Because there's no input. There's no input to the server in this case to validate, right? Like any validation needs to be done client side. And then it also, outputting coding to try to prevent, traditional stored or reflective cross-site scripting, that's already happened because that happened server side, not client side, right? So the TLDR or the nut of what we're talking about here is this is really hard to defend against because it happens entirely on the JavaScript side, right? And I don't know if you've ever written JavaScript, it's really convoluted in many cases. So like it's really easy to accidentally end up in here without realizing that you've done it. So what can we do with it, right? Well, there's session abuse. What if I do the Java, in many cases, it's the same things we can do with other cross-site scripting. I could inject the JavaScript fragment that just sent your session over to a server I controlled so I could capture your session token, right? Like I could harvest credentials. I can harvest anything that is stored in the DOM in your browser, which is a lot of data that you're intended to see and a lot of data that you're not intended to see that ends up living there, right? Like you get a JSON object back and oftentimes that entire object is persisted in your DOM somewhere and only the components of it you care about are sucked back out. Right, I can do UI manipulation. I can replace elements on the page. This is often used in cross-site request forgery, which obviously we haven't talked about yet and we'll get to later. So a particular interest here, right, is I discussed pretty at length last time how HTTP only is, it's a methodology that's used to prevent access to cookies, right? Like it means that JavaScript can't access it. But because this is code running entirely client-side, and this goes for the other cross-site scripting too here, but it seems more relevant here because of how these attacks are generally abused. I'm running JavaScript in your browser as your user. Do I care if I have the cookie? I can just act as you. Anything you can do interacting with this page, I'm in your browser now. I can simulate clicks. I can change the page you're logged into. I can just call backend APIs. And you know what? Your browser is still going to send that cookie, that session cookie to the browser or to the server. Like I don't need to steal the session cookie. I'll just use you as a man in the middle. Like what happens if I basically use JavaScript to make a proxy? Like I don't even need the steal the session cookie in this case. So how can we defend against this? Well, the biggest, simplest thing we can do is be careful where we're syncing data, right? Like wherever we display data, we need to be really careful about how and why we do that, right? Like if we're going to do that, instead of using inner HTML, use text content, use inner text, right? Like these interact with the text on the page, but they don't interpret and they don't run any embedded HTML code. They don't render the HTML code, and they don't run any JavaScript, right? So these are APIs that don't execute code. But the biggest thing there is treat browser data as untrusted, right? Like generally, if you take one lesson out of this class, don't trust things. Don't trust users. Users are bad. They do bad things. Now, most users are good, but there are bad users that do bad things. And if you trust them, then you're going to get burnt with it. So we'll take a second here and I want you to internally think about what did we break here? Is the server broken? Have we abused the server? Have we abused the browser? And have we abused JavaScript logic? I mean, the answer is more than one of these, but I'll probably start class next time with a quick overcap, and I'll ask this question again, and I'll ask you guys to answer it, you guys and girls to answer it. So why does this matter from our perspective? Well, you know, the biggest thing here is so often teams, blue team especially, you're so focused on protecting the server that you forget that the client exists too, right? Like, I've seen so many application pen tests that they don't look at the JavaScript. They don't look at what's running in the browser. They're focused on ways they can abuse the server. They're looking at reflective and stored cross-site scripting. They completely miss this, and it's easy to miss. These attacks can be really complicated. It can be really hard to understand the data flow that actually happens here, right? It's why it's hard to talk about. It's why it's hard to have an explanation about. It's why it took me it's why it took me a half a plane ride to Houston to get my head around this well enough to be able to explain it to all of you, right? Like, but this matters a lot because as we move in this world from largely client server based things where most of the business logic lives on the backend server and is delivered as entire web pages that are rendered, as we move away from that mental model to a mental model where most of the logic lives in the browser and the browser is only requesting the data it needs from the server. And maybe there are some validation rules on saving that data and stuff, but most of the actual business logic lives in the browser. This attack becomes a lot more relevant. So what we haven't covered here, and we'll delay, right? Like, you know, we'll talk about it later if we can get to it. We haven't talked about payload tricks, right? Like, a lot of this filtering has ways to stop it, and there are ways around the ways. It's a game of whack-a-mole. That is going to go probably beyond the scope of this class, right? Like, if I can teach you to do the base attack, then I leave it as an exercise to the reader to figure out how to elevate that attack to something that's gonna pass more complicated cases. Again, we're deferring CSP content. I think what is CSP? It's something security policy, content security policy. I was right. I'm like, is it content? I think it's content. Yeah, content security policy. It controls what we're allowed to load. We're not going to talk about that. And we're not going to talk about how to bypass filtering, right? They're important, but like, again, my goal here is to teach you all concepts, right? It's not to teach you, like, you know, we're 101 level of this stuff here. We're not going to try to do 3 or 401 level attacks here. We're not going to try to bypass defenders that are well equipped here. Like, that is the next elevation and next iteration of where you learn. So that's generally what I had for you. Like, I knew this would be a shorter lecture. I think I'm sitting at like 22 minutes here. I wanted to get you thinking, and I wanted to get you wandering through this and to give you a starting place so that we can do this in practice and we can whiteboard through what some of this looks like next week. Next week will probably be pretty whiteboard heavy, pretty demo heavy. Probably will not be very slide heavy. You know, it's probably 10-ish slides as we go through and review this stuff from a high level, just for those of you that don't actually watch the video. And then we'll move into covering it in person. And we'll go through some DVWA shenanigans and go through it. But that's what I had for you. I hope you enjoy your evening. And again, good evening from Houston. We'll talk to you all later.